Welcome to MRL. In this learning session, we will be learning the solutions of exercise 11.1 of areas related to circles of 10th CBSE NCERT textbook. Now in the first example here, we are given a circle of radius 6 centimeters. We have a circle of radius 6 centimeters. The angle of the sector is 60 degrees. Angle of the sector, that is the sector here is ABOA, and the angle subtended by the sector in the center arc AB is 60 degrees. Now we have to find the area of the sector ABOA. So the area of the sector ABOA is equal to theta by 360 into pi r square. Theta is 60 degrees. 60 divided by 360 into pi into 6 square. So that is 6 pi centimeter square, or 18 integer 6 by 7 centimeter square. So you can remember it as 6 pi centimeter square is the area of the sector. And please remember, in order to solve the examples of area related to circles, you have to remember the formulas which are important and related to the areas related to circles. Then only you will be able to solve the examples. In the second example here, a circle of circumference 22 centimeters is given to us. That means it is a circle of the circumference of the circle is 22 centimeters. We have to find out area of quadrant of circle. So let us understand. Now area of a quadrant means it is 1/4 of a circle, or it is 90 by 360 into pi r square, or pi r square by 4, and we do not know r here. To find r, we are given c. Circumference is 22 centimeters and circumference is 2 pi r. So 2 pi r is that means r is equal to 22 upon 2 pi, or it is 11 by pi. So I can substitute the value 11 by pi here by substituting the value 11 by pi wherever r is there. So it will be pi by 4 into 11 by pi into 11 by pi. Pi will cancel, and we get 11 11s are 121 by 4, and 120 by 4, and it will be 121 by 4, and that will be equal to 77 by 8 centimeters square. So try to understand that. Now coming to the next example, and we are given in the third example number 3, length of minute hand of a clock is 14 centimeters. We have got the minute hand of the clock here with the length of that is 14 centimeters. Now we have to find the area swept by the minute hand in 5 minutes. That means how much area is swept by the minute hand in 5 minutes means we have to find out the area of the sector area of the sector ABOA. So let us see how to do that. Now the area swept by a minute hand in 5 minutes is the sector AOBA, and the angle of the sector, as you know, the total angle described by the minute hand is 360 degrees, and in 5 minutes it describes 30 degrees. So therefore we have got 360 divided by 60, because in one rotation it goes through 60 minutes. So 360 by 60 into 5 becomes 30 degrees. Therefore the angle of the sector is 30 degrees here. Now the area swept by the minute hand in 5 minutes will be equal to 30 divided, that means again using the formula theta by 360 into pi r square. So 30 by 360 into pi r square, 30 by 360 into pi, r is 14, and 14 into 14, and simplifying we get 30, 0 cancels here, 12, 1 by 12 into pi into 7 into, that is 14 7 into 7. So simplifying we get 49 pi by 3, and pi is 22 upon 7. So 49 by 3 into 22 upon 7 becomes 154 by 3 centimeters square. So the area swept by the minute hand of 14 centimeters length is 5 minutes is 154 by 3 centimeters square, or else we can further simplify it and get the answer as 51.33 centimeter square. So that is the answer for that. Now coming to the next example, we are given a circle of radius 10 centimeters and a chord which obtains an angle of 90 degrees at the center. So we have a circle of radius 10 centimeters and we have a chord AB which is of which obtains an angle of 90 degrees at the center. Now we have to find the area of the minor segment. We have to find the area of the minor segment, that is ABA, and also we have to find the area of the major sector, that is BAOB. So let us see. Now AB is a chord and it subtends an angle of 90 degrees at the center. OA is equal to OB, and that is equal to 10 centimeters. The radius is 10 centimeters. We have to find the area of the minor segment ABA. and we know the formula to find the area of minor segment, and that is area of minor sector, that is ABOA, minor sector minus the area of the triangle AOB. Now the area of the minor sector ABOA is equal to theta by 360 into pi r square. Area of triangle AOB is equal to half r square sine theta, and theta here is 90 degrees, so 90 degrees by 360 into 22 upon 7 into 10 square, because r is 10 here, and half r square is 10 square into sine 90 degrees, because it is sine theta, that is sine 90 degrees, that is sine 90 degrees is 1, and therefore by simplifying we get 190, so 4, and then we get 1 by 4 into 22 upon 7 into 100 minus half into 100, 2 to the 4 to 11 the, so we get half into 100, half into 100 in the bracket 11 by 7 minus 1. I have taken half into 100 as the common there, so half into 100 becomes 50, and simplifying we get 11 minus 1 by 7, that is 50 into 4 by 7, that is 200 by 7, that is 28.57 centimeter square, and that is the area of the minor segment, that is ABA. Now to find the area of the major sector, that is BAOB, simple thing is theta by 360 into pi r square, but here theta is 360 minus 90, that is 270, so 270 by 360 into 22 upon 7 into 10 square, simplifying we get 75 into 22 by 7, that is 235.7 centimeter square. A very simple thing, but remember the area of, what is the formula for the area of minor sector, area of major sector, and also area of triangle. Knowing the formulas, we can calculate very easily. So remember, for calculation of areas related to circles, we have to remember the formulas, the basics of the formulas which relate the areas. Now in the example number 5, we are given a circle of radius 21 centimeter. An arc subtends an angle of 60 degrees at the center. We have to find out the length of the arc, that is AB, and also we have to find the area of the sector formed by the arc. We have to find ABOA, and also we have to find the area of the segment formed by the corresponding chord. That means we have to find ABA. So let us find the length of the arc AB here. Now we know that the formula to find the length of the arc is theta by 360 into pi r, and angle is 60 degrees, 60 by 360 into 2 into 20 by 7 into 21, and by simplification we get the answer for length of arc is 22 centimeters. Now to find the area of the sector ABOA, again formula theta by 360 into pi r square, theta is 60 degrees, 60 by 360 into 20 by 7 into 21 square, and simplifying we get 231 centimeter square. Now area of segment ABA is equal to area of the minor sector ABOA minus area of the triangle AOB, and we already have the area of the sector ABOA is equal to 231, and we have to find the area of the triangle half r square sin theta and subtract it. So half into 21 into 21 into sin 60 degrees, 231 minus half into 21 into 21 sin 60 is root 3 by 2, and simplifying this we get 441 into 1.73 divided by 4, or 231 minus 190.7, and that is 40.3 centimeters square is the answer. So try to understand the calculation. Calculations are very simple. Remember the formulas and solve it. Now coming to the next example, that is example number 6, we are given a circle of radius 15 centimeters. A chord subtends an angle of 60 degrees at the center. We have to find the area of the minor segment ABA, and also area of major segment BAB, major segment, that is BAB, ABA and BAB. So let us understand how to do that. Now area of minor segment ABA is equal to area of minor sector ABOA minus area of triangle AOB. Now area of minor sector formula is theta by 360 into pi r square, and triangle is half r square sin theta, and theta being 60 degrees, 60 by 360 into pi is 3.14, r square is 15 into 50, and minus half 15 into 15 into sin 60, half 60 it becomes 0.66, okay, we have got 1 by 6, 36, 1 by 6 into 3.14 into 225 minus half into 225 into root 3 by 2. Now if you see in this, 225 is common, I have taken 225 outside, 3.14 divided by 6 minus 1 point, root 3 is taken as 1.73 divided by 4, and simplifying that we get 3.14 divided by 6 is 0.523, and simplifying 1.73 divided by 4 we get 0.4325, adding them or subtracting them we get 0.0905, multiplying we get the answer as 20.363 centimeters square. So that is the approximate answer for the area of minor segment. Now the area of major segment can be easily found out, that is BAOB you have to find. We have to find the area of the circle first, subtract the area of the minor segment. So area of circle minus area of minor segment will be the area of major segment. Area of circle is pi r square minus 20.363, and pi r square will be 3.14 into 15 square, and that will be 706.50 minus 20.363, and we get the answer as 686.137 centimeter square, and that is the answer for the area of the major segment. Now coming to the next example, that is example number 7. We are given a circle with center O. The radius of the center is 12 centimeters each, 12 centimeters, and a chord subtends an angle of 120 degrees at the center. We have to find the area of the segment formed. Now area of segment is ABA, so we have to find the area of the segment ABA, and the formula is very simple again. Area of minor sector is ABOA minus area of the triangle AOB, and that is half r AOB, that is half r square sin theta. So theta by 360 into pi r square minus half r square sin theta, and theta, as you know, it is 120 degrees here, so 120 by 360 into 3.14 into 12 into 12 minus half into 12 into 12 into sin 120. Here you have to be very careful. Here angle is 120, therefore we cannot take sin 120 directly, because we have to find out by subtracting 180 we get sin 180 minus 120, and sin 180 minus 120 is sin 60 degrees. So therefore remember, sin 120 degrees is equal to sin 60 degrees. So therefore I have replaced sin 120 with sin 60 here. Now simplifying again, putting the values here, we get 1 by 3 into 3.14 into 48 minus 6 into 12 into sin 60, that is 3.14 into 48 minus 612, that is 12 6 is 72 into sin 60 is root 3 by 2. Again further simplifying, we get 150.72 minus 62.28, or the answer is 88.44 centimeters square. So we have solved 7 examples here. Up till now, what we have to only remember is the formulas of each of the if you remember the formulas, we can solve the examples very easily. So formula of area of minor sector, formula of minor segment, or formula of the triangle is what we have to remember, and substitute the values and get the answer. So the examples of areas related to circles are very easy, provided you know all the formulas and the basics of circles and the formulas of the areas related to circles. Okay, remember this, note down, and keep them in a note down in a book, and practice them, and you can keep them as a reference for your future use. Okay, thank you.